Hello and welcome back to the channel. Today we are going to start with SQL fundamentals. Now, in this video, we will start with database creation and go up to practical application. All of these steps will involve the basics of SQL you need to know. So, the first step is how you can create a database. For that, you use a command create database name. For example, we need to create a database named LML. We will use the keywords create, database, LML and semicolon. This is very important. Now, when we need to use the database we created, we use the command use. Use database name. Let's say we need to use LML, so use LML semicolon. So the database LML will be selected for the operations. Lastly, if you want to check if a database is created or not, if there is a database by the same name in the system or not, then show database is used. So, when you run this command, all the databases in your system are listed. Next up is how we create a database. So, this is how you can create a database in the existing DBMS, like create database named company DB, character set and collate. These might be some new terms that are used in certain SQL management systems where the character set and collate is a database configuration that defines how text data is stored and sorted in your database. The next command is create database if it not exists. Test DB, drop database if exists old DB. What does that mean? That you need to create a database, test DB, if it does not exist, and you need to delete the database if it exists named old DB. Next, now you know how to create database without tables, it is incomplete. So here's how you can create a table quickly using the create table command. Then you need to write the table name. For example, here it is employee, and then you need to specify the attributes along with the data type. Like ID is integer, name is varchar 50, that means character of length 50 can be added to this attribute. Then attribute age with int as the data type. Lastly, salary with data type decimal. 10 and 2, what does that symbolize? 10 digits before decimal and 2 digits after decimal. Next up is creating tables with advanced constraints. So here if you just want to specify a primary key and just say that it auto increments, then you can specify it when you're creating a table. Like for name, you add the condition that it is not null, email should be unique, age should be greater than equal to 18, default salary to be 0, and there is a foreign key of department ID with a reference from the table departments where ID is specified. Now, this is simply how you can just create a table using different data types like int, varchar, text, decimal, delete, date, time, date and time both, block. Moving on to the insert into statements. Using this statement, you add values to an existing table. Like we need to insert into all columns, we use insert into table name, that is employees, values, that is the ID, this is the name, age, and salary. These are the attributes are being adding into it. Next, if you want to insert into specific columns, like insert into employees, you just write the columns, like we need to just enter the data into name and age, and then values as Jane Smith and 25. This enters into the name attribute and this into the age. Then we have, if you want to insert multiple rows. Similarly, you separate them by a comma, and rest the format remains same. At the end, we need to add semicolon. Now, if you want to insert using the select command, simply insert into employees backup, select star from employee where age is 30. Next, if you want to insert with specific select, like we need just specific attributes and a condition to insert the values. Lastly, if you want to perform some calculations, like here we are multiplying the salary by 12 so that we can get the annual salary of the employees. Now comes the select clause, like select star from employee, that implies all the attributes from the table employees will be selected. Next, if we want to select some specific columns, like we only want to select name and age from table employees. Select with alias. Alias are something like you can rename an attribute or a column. Like here, we are renaming name as employee name, age as employee age from employees. Now, if you want to select distinct values, we can use the keyword distinct that will only give us distinct department IDs from the employee table. Now, if you want to perform some mathematical operations along with our select clause, we are free to do so. So here we are selecting name and salary and multiplying the salary by 12 and making a new attribute as annual salary for this particular statement from the table employees. So just the output will be name, salary and salary multiplied by 12, but this won't be written like this. The name of the attribute will be annual salary. We can also perform string functions using the select clause, like we can just change the case of name to upper or lower and then have the length of the name from the table employees. Aggregate functions can also be performed like count star that will count all the entries into that table, maximum salary, average salary, minimum salary, and the sum of all the salaries of the employee from the table employees. Then we have date functions. We can select name, that is, we can select year, month from employees. We're easily able to calculate the hire date of that particular employee from the data. Now comes the from clause. It is just like a reference, like we need to select all the attributes from the employees table. We can just have database name along with the table, like the database here is company DV and the table we are referring is employees. Understood previously about alias, we can just select e.name, e.salary from employees, specifying employees as E. Now comes from clause with multiple tables, or you can understand them as joins. The first one is inner join. This might be complicated for you to understand. Let's say we have two tables, E as employee, department as D. Inner join, what does it does? It just takes out the data that is common for both the tables. And this is how you can write it. Select E.name, D.department name from employees E, inner join departments D. Where you will perform the join, there should be a common attribute between those two tables where you are performing a join, as it won't be there. Here we are considering E.department ID and D.id as our parameter on which we are joining these two tables. Next is the left join. You just need to replace the name of the join and what attributes you want and on what attribute basis you are joining those tables. For the left join, let's say this is table employee, this is table department. From the left side, all the data is considered. Next up is right join, similarly left to right. Now this is table E, this is table D. The right side of the entire E and D is the output of this particular segment. Next we have the cross join, where all the values from both the tables are output. Cross join is also known as full join. Next up we have the where clause. Here we are selecting all the attributes from the table employee where the age is equal to 30. Next, we can have when it is not equal to can be represented using these two notations. Then we are looking at if salary is greater than 50,000 or age is less than 35. Then we are combining greater than equal to and less than equal to, like salary is greater than equal to 50,000 and age is less than equal to 30. Now here's the catch. When it is only less than, then 35 is not counted. But here it is less than equal to, then 30 will also be counted. Same for salary also. Now comes pattern matching, where first is the like operator. Like we are using where name like J%. It means that J should be the starting letter. Rest could be anything like John, Jake. This can come as output. Then we have like percentage son. That means in front it could be anything, but it should end with son. Then we have the condition percentage OH percentage. That means it can be anything in front. It should be OH together and it can end with anything. So next we have wildcard patterns. We need to select every attribute from employees where name like J space HN. Like J can be followed by any character and it should end with HN. It can be A, it can be O, it can be I, whatsoever. Now, if it is case sensitivity, then we just add on that where lower name like John percentage. Like it should start with John and end with anything else. Then we have the between operator. That means age between 25 and 35 employees will be the output of this statement, and for the next employees having the salary between 50,000 and 60,000 will be the output. Then we have the in operator that basically specifies the range that department ID should be 1, 2 and 3 for the output to be true, and similarly for the names it should be John, Jane and Bob. Not between and not in, that are just negations of operators that we understood. Moving on to the null handling, like we need to select all the attributes from table employees that phone is null because there is no value in phone and there is no value in email. Next, that it is not null, that means phone has certain value and email also has certain values into it. Then only it will be considered as the true output. Now, if we want to handle null, we can use this command or we can use this keyword where it will replace every occurrence of in the attribute phone that is null to no phone in the table employees. Then we have the AND operator. It is just like the Boolean AND. For the condition to be true, the age should be greater than 55 and the salary should also be greater than 40,000. Now, if you want to have 3 conditions, that means age should be more than 25, salary should be more than 40,000 and the department ID should be equal to 1. Anything else is false. Mixed conditions is like we can just have some pattern matching, we can add between operator. We can also use AND with OR. Instead of AND, you can also write OR. It's the same thing. Like first, these 2 conditions will be checked. The output will be in OR with this condition. Next comes up the OR operator. For this, there is no need of both the statements or both the conditions to be true. Just one is true, then the output is also true. If we want to add multiple conditions, we can use the similar way we were using in the AND operator. We can also mix this with AND as we can mix AND with OR. And we can just add on pattern matching and logical operations, arithmetic operations to make it more complex. Then we have the NOT operator. It is like the negation operator. Like we need to select where the age is not 30. It can be 25, it can be 40, it can be 60, but not 30. Where department ID is not 1. Department ID can be anything up to N but cannot be 1. Where name not like J person, where any name starting with J is not acceptable. Where the age between 25 and 35 is not acceptable. Similarly, the in condition and the phone cannot be null in this statement. Then the delete statements. Like if you want to delete a specific row, we can just specify that ID equals 1, it will be deleted. Where age greater than 65, all the rows will be deleted. Where department ID is 1 and that means both the conditions should be true and salary is less than 30,000, all the rows with such conditions turning out to be true will be deleted. Lastly, delete. From employees, all the rows in the table will be deleted. Next is continuation, like with subqueries you can use, with joins you can also delete, and you can also limit, like only 5 rows can be deleted where age is greater than 60. That's how it works. Moving on to the drop statement, like drop table employees, it completely deletes the table employee. Delete statement, what does that do? It deletes the rows. And drop, it deletes the table. And similarly, if exist is used, if you want to delete multiple tables, you can just write it like this. And if you want to remove the dependent objects from that table, so you can just use the cascade keyword. Moving on, you can just drop the database also, and if exists also use, and if you want to drop it with some specific conditions, you can drop the database using that also. That's how these three will be used. Then we have the truncate statement. Truncate table employees. It removes all the data, but the structure is intact of that table. Now let us understand what is the difference between drop, truncate and delete. So delete is a row by row function and you can roll back it, but it is slower. Whereas truncate is a page by page function. It is faster than delete and you cannot roll that back. Once it is done, it is done. It is permanent. And it also resets the auto increment. Lastly, the drop, it is a complete removal process. It cannot recover without backup. That means if you drop the table, if you drop the database, you can only have it back when you have the backup, else there is no chance. A practical example of employee management, a quick example that we select all the attributes from the table employees. With salary, we need to select average salary from employees. Then we need to list employees by department with salary info. Here we use the join. By default, it is always an inner join. Then we have update and delete in combination. You need to delete from employees where ID is specified by a condition that last login should be less than this date. So that's all about the basics of SQL right now. In the next video, we will move toward the intermediate phase of learning SQL. And I hope you found this video helpful and it helped you learn the basics of SQL. And if you found this video really helpful, please do give it a like, share it with your friends, and don't forget to subscribe to the channel to help us grow. I will see you in the next video next week. Till then, happy learning.